Welcome to the channel. So here we are discussing the question, find the maximum number of fruits collected. So the question states that there is a game dungeon comprised of n cross n rooms arranged in a grid. You are given a 2D array fruits of size n cross n where fruits I, j represent the number of fruits in the room I, j. Three children will play in the game dungeon with initial position at corner room 0, 0, 0, n minus 1 and n minus 1, 0. The children will exactly make n minus 1 moves according to the following rules to reach the room n minus 1, n minus 1. So the child starts from 0, 0 must move their current room I, j to one of the rooms I plus 1, j plus 1, I plus 1, j and I, j plus 1 if the target room exists. The child starting from 0, n minus 1 must move from their current room I, j to I plus 1, j plus 1, I plus 1, j and I plus 1, j plus 1 if the target room exists. The child starting from n minus 1, 0 must move from their current room if one of the rooms I minus 1, j plus 1, I, j plus 1 and I plus 1, j plus 1 if the target room exists. When a child enter a room, they will collect all the fruits there. If two or more child enter the same room, only one child will collect the fruit and room will be emptied after they leave. Return the maximum number of fruits the children can collect from the dungeon. So, according to this, what is meant is the three children are starting from different rooms and need to make exactly n minus 1 moves and want to reach the room n minus 1, n minus 1. So it is clear for the first child that from 0 to n minus 1, this is the moves we want to make for the rows and for columns as well. And there are exactly n minus 1 moves for him. So the only possibility is for the first child to go via the diagonal. So there will be n minus 1 moves and he will be able to reach n minus 1, n minus 1 room. So hence for the first child it is sorted that he will go by diagonal. Now going to the second child. The second child can have any of the moves from I plus 1 j minus 1, I plus 1 j and I plus 1 j plus 1. So for the second child we can go with the recursive calls and check for each of the moves, and wherever the value becomes maximum for the number of fruits collected, we will choose that path. And similarly for child 3. And after doing all these things, we will calculate the total fruits and return the answer. So for the first child it is a direct path. The direct path is the diagonal path. So for first child it becomes 1 plus 6 plus 11 plus 1. So that becomes 19. And then we go to the next child. The next child is starting from 0, 3, then 1, 2. So he is starting from this point and then he is going to 1, 2, that is this point. Then he moves to 12 and then he reached the final step. And the next child who is at n minus 1, 0, he will move to this and then this. So total 100. Because why 1 is not counted? Because here the first child reached and the value for this won't be counted now. Hence, the answer would be 19 plus 4 plus 7 plus 12 plus 13 plus 14 plus 15, which will be equal to 100. Hence, 100 would be our answer. So, we have figured out how to do this. First, we would be moving diagonal for that child, the first child, because we need exactly n minus 1 steps, and going diagonally would require exact n minus 1 steps, and we would reach the destination. That is the only one possible solution for the first child. For the second and third child, we will do recursive call for each of the path which are mentioned, and then we would calculate the maximum, and hence the total would be the sum of all the fruits which are given as the answer from the three steps. So let's see the solution here. So here we have a fruits grid, and the total fruits are 0 initially, so hence we add the diagonal elements here. This means the fruits for child 1. Now after this we go for recursive calls for child 2 and child 3. So let's see the calls for child 2. When we go to child 2, whenever our row and column both becomes n minus 1, we return 0, which means we exit out as we have reached the destination, and the destination value is 0 for us. Now we check the fruits would be the current fruits, plus we would collect the fruits from I plus 1 comma j minus 1, that is row plus 1 and column minus 1, I plus 1 comma j, and I plus 1 comma j plus 1. All the three conditions are taken, and we will find the maximum out of all the three. Whatever comes the maximum will be returned as the answer. After this we go to child 3. In child 3 also same procedure would be followed, only as you see in child 3 it was asking for I minus 1 j plus 1, I comma j plus 1, and I plus 1 j plus 1. So the same conditions are written here, I minus 1 j plus 1, I comma j plus 1, and I plus 1 j plus 1. So we have maximum fruits as the maximum value we have stored, and the maximum of current fruits plus collecting the fruits from the other room which is at I minus 1 comma j plus 1. Similarly, I comma j plus 1 and I plus 1 comma j plus 1. Checking all these three conditions, we return the maximum fruits which we got from child 3. Now here, as you see, we are storing it in a dynamic array. That is done so that if a value is already present there, we can extract that value and we do not need a recalculation. So suppose if we go on the same row and column again, then we do not need to calculate the whole value again, just we will return the one which was stored in the array. So here we have taken two dp1 and dp2 for child 2 and child 3, and hence we are storing the values in them. After completing this, we will return the total fruits which will be our answer. So this is a very easy solution, very easy approach. Once we think of how child 1 would get the fruits and how child 2 and child 3 would do it. Other than that, the solution is very simple. So I hope you all understood the solution. If you have any doubts, please post it in the comment section. Thanks for watching.